Alright guys, here we go. One more interesting substitution for integrals. Now I just want to remind you, the reason why we're doing this is because if I were to do what I normally would think of and do something like this where I go 25 minus x squared and make that to the 1/2, which of course I can't distribute because there's a minus there. And then I were to say, oh well, let's just try the middle u. So we go u equals 25 minus x squared and du equals negative 2x. Du dx, and from that point we're kind of in a little bit of trouble because I can't get a negative 2x in there. You're not allowed to put a negative 2x inside and then 1 over 2x on the outside. That's a problem. Okay, you can't just add random variables in because you know that the product rule doesn't work for integration. Okay, nor can you break it up if you've got the x there. So what we're going to do is just go ahead and get rid of this. And we say, okay, well, this isn't going to work the way that I'm used to. And so what I'm going to do is I'm going to go look at my formula sheet. I'm going to say, okay, well, remember there's these things with this weird substitution. And I got the 1 minus x squared. I got the 1 plus x squared. And then remember you got the x squared minus a constant, which is the secant. So we got a constant minus x squared. And so because it's a constant minus x squared, we're going to say, okay, let's try using sine. Alright, so we're going to go into sine, and we're going to say, alright, we're going to say x equals, and then it's going to be a sine of theta. Okay, so a is the number in front. Okay, so we'll just square root of the number in front because this is a squared minus x squared. And so a is going to be 5. And then we got sine of theta. Now, of course, that means that sine of theta equals x over 5. And that means that dx d theta is 5 cosine of theta. Or, in other words, that dx equals 5 cosine of theta d theta. And so from here, we're going to go ahead and put some substitution in. So we're going to go integral of square root of 25 minus x squared, but instead of x we're going to put in 5 sine of theta squared, and instead of dx we're going to put in 5 cosine of theta d theta. Alright, so we're looking pretty good. We're going to keep moving from there. And so we're going to go, okay, let's simplify the inside there. Integral of square root of 25, and then that'll leave me with 1 minus sine squared of theta, right? Because I got the 5 squared, I got the sine squared, and I take the 5 squared, which is 25, and I pull it out. And then I've got 5 cosine of theta d theta. And so from there we can square root the 25. We also know that sine squared of theta plus cosine squared of theta equals 1, which of course means that 1 minus sine squared is cosine squared. So we're going to go ahead, and that means we've got integral of square root of 25 cosine squared of theta times 5 times cosine of theta d theta. Man, I should like totally sing these. No, that would probably annoy you. Not that I care. I'm not there anyway. Okay, so then we take the square root, and then we've got 5 cosine theta d theta, and we end up with the square root of 25 cosine squared theta d theta. Now, you remember how we take care of cosine squared of theta, don't you? Don't you? Well, we take the cosine squared of theta, and the first thing we're going to do is we're going to turn it into the double angle formula thing. So we go into the formula booklet. I'm just showing you this so that you remember. You should be able to do this probably without the double angle formula thing now. But cosine of 2 theta is equal to 2 cosine squared of theta minus 1. So we go straight into that, and we go cosine of 2 theta. Let's do it in a different color because I'm doing my side work. So I go cosine of 2 theta equals 2 cosine squared of theta minus 1. So I add the 1, so I got 1 plus cosine of 2 theta all over 2 equals cosine squared of theta. And so then I put that in. So I go integral. I say integral of 25. You know what, let's put that 25 out front because it's getting annoying. And then we put in the 1 plus cosine of 2 theta over 2 d theta. And at this point, you should be able to take the integral. And so we're going to take the integral. And actually, I'm going to move over here. I'm going to leave some space in the middle because I'm probably going to need to do a little bit more work later. And so we go 25. And then I got 1/2. Integral of 1/2 would be 1/2 theta. And then I got plus. The integral of cosine of 2 theta would be sine of 2 theta. But because it's a 2 theta, I got to put the 1/2 in front. So then I got 1/2 sine of 2 theta. And of course, don't forget your plus c. Plus c! And at this point, I need to be able to do sine of 2 theta. Now remember in the last problem, what we did is we said, hey, let's make a little triangle. We made a little triangle. And we said triangle because sine of theta was x over 5. So if this is theta, sine is opposite over hypotenuse, which means that this side right here is going to be the square root of 5 squared minus x squared. Okay, so then I can do, I can't do sine of 2 theta because I don't have a triangle for sine of 2 theta. So we're going to have to use a double angle formula. Man, this is an awesome question. You know you're going to see something like this. So we're going to go 1/2 theta. And I'm going to turn the sine of 2 theta into 2 sine of theta cosine of theta. Don't believe me? Don't believe me? Yeah, you should believe me because there it is right there. Sine of 2 theta equals 2 sine theta cosine theta. Alright, back. Oh, no, just kidding. Back to this one. And we go 2 sine of theta cosine theta, which leaves us with sine of theta cosine of theta plus c. Alright, so at this point, we can go ahead and we'll do some distribution. We'll find sine of theta cosine theta. So we'll go 25 over 2 theta. Plus, now sine of theta is opposite over hypotenuse, so that's x over 5. And cosine of theta is adjacent over hypotenuse, so that's the square root of 25 minus x squared all over 5. And so if we put all these together, then we end up, you know what, I didn't put this theta back in. Let's put that theta back in too. So that one I'm just going to get from here, theta equals arc sine of x over 5. And this should finish it off for us. We're going to go 25 over 2 arc sine. Now remember last time we had to do a little bit with it because we didn't really want it in cosecant, but sine's okay. So arc sine of x, and this is fairly simple, straightforward. Plus, and then I'm going to have x over 25 times the square root of 25 minus x squared. And that'd be about it. Except for, of course, the fact that this is supposed to be in parentheses and I didn't distribute the 25 over 2. Yeah, you'd think I forgot. I didn't forget that c either. So when we do distribute this, we'll have 25 over 2 arc sine x over 5. And then that will give us x over 2 times the square root of 25 minus x squared. Gotcha! All right, there you go. Try some on your own now.